Hi, everyone. Thanks for having me. My name is Brianna, and I'm a geographer at Ecopia AI. We are a partner organization of Airbus, so we work very closely with HD15 imagery as we use that imagery to extract high precision vector data for a variety of use case and mapping applications. So I'm excited to be here today and share a little bit more about the importance of high definition mapping, the role that AI and imagery play in that mapping, as well as a specific HD15 use case that we collaborated on with that Ecopia and Airbus have collaborated on around facilities management. And then I'll finally wrap things up with a brief overview of how high resolution imagery like HD15 is helping us build a digital twin of the world. So why do we need HD maps? I mean, I think everybody here knows that the world is changing incredibly fast every day, from the natural environment with climate change to also the built environment and how we as humans interact with the world. Things like population, migration, land use change, urban development, even just infrastructure aging and losing quality and safety standards. All of that is changing every single day and contributes to our overall understanding of some of society's most complex challenges, like climate resilience, public safety, public health, equity, sustainability. All of these challenges and initiatives that are really pressing for today's governments and organizations worldwide require high quality mapping data. And that starts with imagery like HD15. But at Ecopia, what we do is we take that imagery as a foundation and then extract vector features to get even more value out of that high resolution imagery. So we produce vector data that is essentially, interactive map layers that organizations can use in their geoprocessing and analytics functions to better understand the world around us and how fast the world is changing. So how do we observe change in the world? It all starts with imagery. There's so many different ways to capture geospatial imagery, whether from satellites, planes with cameras on them, street view cars driving around, people with cell phones or drones can even capture geospatial imagery. And there's, certain specifications and I guess pros and cons to any type of imagery that you're using. But what really sets HD15 apart, especially when we're using it with our clients and collaboration with Airbus, is that you get all of the benefits of satellite imagery constantly capturing images. When you have airplanes or street view cars, you're reliant on how frequently those cars or planes are running and capturing imagery, whereas satellites are there all the time. But you also have that high resolution with that 15 centimeter resolution that allows us to extract features completely and accurately. So you really are able to hit on all three of those data metrics that I just mentioned. So HD15 has been really great for us as we have been working closely with Airbus and our clients to produce high precision maps of the world. And what this ultimately results in is interactive vector data layers that detail all of the individual features of our physical world. So we can transform the raster data or the images into classified vectors. Here you can see an example of a neighborhood in the Chicago area of the US and all of the different transportation and land cover features that we are able to extract from high resolution imagery. Again, planimetric level detail, so it's accurately representing what is in the real world. And there's a complete representation. And as long as we're getting constantly updated imagery, we can keep extracting this efficiently to ensure that those maps are up to date. So how do we do it? Well, at Ecopia, we've developed an AI that essentially ingests imagery and then extracts vector features from that imagery with the same level of precision that you would expect from a trained geospatial professional. So we're able to produce these maps at high quality, but also high efficiency. So we're not sacrificing on any accuracy or data metric like that, but we're also keeping data up to date with the real world change that is occurring every single day. This is not always possible with manual digitization. So, with manual digitization, it's pretty accurate because typically there's, highly trained geospatial professionals manually tracing features. But if you think about a large scale project, this is going to take a really long time. You might have multiple people working on this project and they all interpret the image differently. No matter how high resolution the image is, somebody might think, a building starts in one location and ends in another, or people might have been trained differently on how to digitize. Data is not normalized. This can take a really long time, is very expensive when you consider the time and resources that are invested, people's salaries. And then you have to keep data up to date and you have to start the whole process all over again. Traditionally, that's how vector data is extracted from high resolution imagery. There are some automated softwares out there that extract features, but they tend to lack the accuracy and completeness that most organizations require to be confident in their data for decision making. So even though it might be faster and cheaper and you can keep things updated, the accuracy, completeness is not there, and you're going to have to compromise on something. Traditionally, this is what organizations have dealt with, even if they have the best imagery out there. If they're trying to get actionable data in a vector format, they had to choose between one of these two options. But at Ecopia, we've developed an AI that ingests raw imagery and runs it through machine learning algorithms that are developed by trained geomatics experts. Then that data goes through a human-based quality control process, and then we ultimately produce the vector layers that we are confident in as a team of geographers, but has been produced so efficiently because of AI that we can keep maps up to date and run this process multiple times to detect change over time and keep maps up to date with the real world. And every time that we run this process or create a product, our systems get better and better because our vector layers go back into that machine learning algorithm to train our AI. So we're constantly improving, and now we're able to produce a vector map of a average to large size city in a matter of weeks. So it's very easy to keep our foundational digital twin of land cover, transportation, whatever type of data you're looking for, up to date with real world change without any manual digitization. So people don't have to choose between manual digitization and automated software and the pros and cons that come with each of those. We're able to deliver on everything. We can produce complete, accurate, and up-to-date data very efficiently. We also tend to be 80% cheaper than traditional data extraction services. So really, you're not compromising on anything, whether it's timeline or costs. Keeping data up to date, we can run that as frequently as needed. And data is all normalized because our team has devised an AI that is perfectly aligned each time we extract. So you don't have multiple different definitions of, what is a building, what is a tree, things like that. We define whatever you need for your specific area of interest and the imagery that we're working with. And we guarantee a geometric accuracy of 95% or higher. All right, so what does this look like in action? So recently we worked with Airbus by extracting vector data from HD15 imagery for a facilities management use case. So the end client in this case was actually Airbus Commercial, the arm of Airbus's business that manages planes and airports, things like that. They manage over 300 sites around the world, and typically all of these sites have been, cataloged in some way with geospatial data, but all with varying methodologies, update schedules. So the data was not normalized. And it was very difficult to have uniform planning across this facility management and real estate department. It was really difficult to have uniform planning and decision-making across all of the sites because the different sites were mapped at different times of year or maybe different years in general. So some maps were really stale, some were more detailed than others. Some didn't include all of the data layers that were needed for whatever analytics was being run. So we ingested Airbus Geospatial's HD15 imagery, and we were able to capture for 72 most critical sites out of all of the sites that Airbus manages. We were able to capture the same uniform data layers across all of these sites, the same vintage, the same timeline, so that there was a uniform data representation for these maps. So now Airbus Commercial uses this for security, logistics planning, sustainability planning, and has even used this data to inform the rollout of a new fleet of vehicles. You can see the map image here of the airport in Toulouse and a legend showing all of the different data layers. But again, because HD15 is so high resolution and can be captured around the world very frequently, we were able to produce uniform maps around the world for all of these very diverse sites, but with the same uniform data specs, so that Airbus Commercial now has a digital source of truth for their 72 most critically important sites. So here's a more zoomed in view where you can see the image and then the data that we ultimately extracted. Again, there's just a very high level of detail, both in the image itself because it's HD15, but then also in the vectors that we were able to produce. So that's just one example of how we are building a digital twin with HD maps. HD15 from Airbus is a core component of this for many of our projects. Ultimately, we are producing not only the vector data, both 2D and 3D, to form the foundation of a digital twin, but we also append attribution, whether that's heights of buildings and bridges and trees, or maybe the width of sidewalks, crosswalks, any change detection, attribution, what's the status of a certain area of road or a building, something like that. We are also appending attribution like that as we are developing a digital twin using high resolution imagery that is then ingested into our AI to extract the vector features themselves. So we work with many different companies, many different organizations around the world. Everything has a geography, so everything can be mapped. So with AI-based mapping, we are able to build a digital twin of the world layer by layer. And we are excited to continue our partnership with Airbus and working with organizations like those that you all work with here on the call. So if you have any needs for extracting vector data at scale and high precision from HD15 or other Airbus imagery, let us know. We're happy to help you with whatever your use case might be. That's it from me. Thank you so much for having me.